Hello, guys. Welcome to another EBPF Chirp episode. Today with us is Rafael David Tinoco. He's working as an engineer at Garnet, developing Gibril. So please, Rafael, introduce yourself.
Well, pretty much it. I started long time ago. I passed my life like dealing with mainframes and high-end machines and operating systems internals. And like 5 years ago or so, maybe a little bit more, I got into touch with eBPF, where I started playing for IBM hypervisor team, IBM Cloud hypervisor team for some things that they needed. Then I maintained Tracy for Aqua Security for some time, and now Garnet founders like called me in so we could start this project that we're talking about, Jibril, which has been an amazing trip so far.
I remember our conversations, I think about a year ago, when you guys were still pretty much focused on GitHub Actions runtime security, if I'm correct. But now you're also tapping into Kubernetes runtime security, right? So help me understand how everything evolved. Where did you guys start? What problems were you trying to solve initially? And yeah, basically how it evolved over time.
Yeah, so founders' visions were from the beginning was that they wanted context of whatever was happening, right? Independent of what we would provide at the endpoint. We knew that with AI, whoever held the best context about of what was going on was going to succeed. So one of their bets was in the engine, which is Gibril, independent of the Go. Back then, we mapped that CI/CD was like a very nice niche to play with, and then since for the engine doesn't matter where you're running because like we're trying to make a very low footprint engine, so if it runs in GitHub or a toaster or like the high-end server, that's our goal. And then Kubernetes was just the natural move. I mean, and it was part of like the people installing Jibril and asking us things like, so one of the first requests were, oh, can you create a deployment service file for me? And then suddenly we installed into a base and then, hey, can you provide me a Helm chart so I don't have to deal it? So it's like it was a natural
Yeah, I
involvement.
think then, yeah, also the transition was probably quite seamless because GitHub Actions are basically just a virtual machine. And when you go to Kubernetes, it's basically similar, just a lot more nodes. And in terms of that, when the number of nodes scaled, what kind of problems did you encounter?
Yeah, so without quoting names, like from the reason why I personally decided to join Garnet was because I had an idea on how to process events in a different way from the regular like mainstream security projects, and that gratefully that has become the differentiator for us, which means that when compared to other projects, like we are in a very, very good shape in terms of like CPU consumption, memory footprint, and scaling. Now it's like before was just a theory, right? But now I can tell for sure that's a reality.
Yeah, but like in terms of, you said you're a lot better. Can you outline some metrics like that give you the advantage?
Yes, I can. I can. So benchmarking is always considered a bit food if you give names, but I won't. So let's do this. So the reason why we are performing so much better is because we're not streaming events from the kernel to userland like all the other two. So if you pick like all the other like Tetragon, Falco, even Datadog agent, like if you pick any other agent right now, they're like basically with this same architecture of streaming events from the kernel, processing the events, and then their competition is about filtering in kernel and making sure that they have the best filters fed from userland. We skipped that approach. It's literally like an in kernel, like a data query model which turned to be very successful, but also some other stuff. Like, for example, I considered eBPF as a premise for more complex data structures and memory allocation. So all that annoyances that eBPF has, like, for example, like a very small stack, or you cannot do X, Y, and Z, we treated those as a premise for something bigger. So one of the examples I can give you was, like, I created virtual maps, which is literally like maps built with maps and more maps. And then you can think of like, okay, this won't scale, but if you compare to any other alternative from the other projects, like, for example, if you have, I won't quote names, but like some agents go and walk all the shards for every time you enter a syscall up to prefix or suffix length and things like that, So we skipped all that just for lookup, so it's pretty easy and fast.
So help me, like, correct me if I'm wrong, but if I understood it correctly, you're basically doing a lot of stuff in kernel, if not everything, and then just exposing it to the user space whenever the user space needs it. So by a simple query, be it like a lookup in the eBPF map or something similar. Is that the right concept?
Almost, yeah. It's almost, because then, of course, like in a simple way, yes, totally correct.
Yeah.
And then we have layers, right? So for example, so all those maps can be checksummed. This is not in the version that we're giving for people to test, but there can be checksummed and make sure that no one is tampering with the maps. And then we have like a userland caching layer. So it's hardly ever that I go again to the map for a same thing unless it's needed. So it's like there are some techniques allowing us to do this in an optimized way, but roughly speaking so it's literally like a database, if you think. It's a database, and then we have those cadences. Like, all the other projects are doing something that is exponentially wrong in my point of view, because when you receive a very tiny event from the kernel, you maximize that event into many things that has to be done. So that doesn't scale if you have this small things continuously happening, right? And I saw this with my eyes when developing other projects, which happens like sometimes workloads can delay detections for 1 or 2 minutes just because you're still processing the buffer. Like, it's not uncommon. And I'm talking about the biggest projects right now. I'm not talking about some
I understand.
minor project. And then with us, I can control these cadences. So what happens is I can, if it's too much for us to do every 3 seconds, then I'm going to do every 9 seconds, every 15 seconds. But the cache will have the information, right?
Nice.
Then there is the quid pro quo of analyzing things and reacting is controlled by you. You can raise the cache and then raise the cadence, or you can reduce the cache, reduce the cadence, but then the CPU consumption is going to be a bit bigger. But like in orders of magnitude less than what they're doing with the other projects,
I think this is amazing. Yeah, to be honest, I never thought about it like this. I think it's an amazing concept. So yeah, quite cool.
Modesty apart, I'm talking about excitement. I don't want to diminish any other projects. It's just like, you know what I mean? Like,
okay, I'll jump a bit forward because I'm interested also in other things. Like Jibril itself is obviously a large project, but you've been also part of Aqua Security, where you were developing Tracy and so forth. So how does CI/CD pipeline, or in general the software delivery of such project, even look? How do you test it? Is there stress testing involved? So how does it look like?
Well, like about Aqua, we were not doing CI/CD up to a point where almost leaving. So it's like they started. There is a guy called Jose and Itai. They I think Itai maybe. And then they were starting putting Tracy in CI/CD. For me, what's natural to put Jibril in CI/CD because of like what I learned from them trying to put Tracy, and out of the box it's not different from starting and stopping the tracer and analyzing the logs. The only thing is that GitHub runners are small if you're not using self-hosted runners. So if they're small, then you have to take care with performance a little bit.
Yeah, I'll paraphrase my question because I think it was misunderstood. But like in
Okay.
general, this is a software itself, and you need to deliver it to like companies. So how do you make sure this
So yeah, I got it. So it's tricky. eBPF, you know the concept of core. Probably you have already written about it. And then the compile once run everywhere idea is very cool. It works. libbpf, for example, and Go eBPF libraries, all the libraries or the loader libraries are doing a very good job in relocating symbols and all, but it's mandatory for you to test in every single kernel version you would like to have supported. And I'm not even saying about like even in between the architecture. So for example, if you're delivering a relocatable static binary for AMD 64, then make sure to test in ARM 64 because ARM 64 isn't good before version 6.1, for example. So make sure your code runs in all of those, and especially the combination of kernels from cloud providers you want to support. I'll give you an example. I was almost sure that we were good for 5. For AMD 64, like 5.15, and our like first big project called us and said, "Oh, but I use 5.10 in Amazon 2." So it's like, okay, and then it's support, and then it's complicated because you're using set of helpers and things that you have, okay, I have to rethink 10% of my code now just because of this.
Yeah.
So,
And okay, but what about in terms of stress testing and let's say performance optimization? Is there a smart way to actually test the eBPF programs, or are there just dummy ways of
okay.
a lot of
Yeah, so like you were saying specifically about the hook handler and its performance, the instrumentation.
No, I mean in general, like you have an eBPF product and now you say, oh, it can handle 600K events per second or similar like that. Is there a smart way to actually validate this, or is there just a dummy approach where you're just basically generating a lot of kernel events?
Yeah. Yeah, so there isn't I've seen some projects that I cannot name right now, but I've seen some projects that are instrumenting BPF objects with like performance metrics
Hmm.
in a way that you can pick like the average consumption of each hook and sum into the logic that depends on how many hooks it uses and all. I'm not doing that yet because since there is no standard, if I choose one, I'm worried about the future and having to change it all. But what I've been doing is that during my stress tests, I monitor like CPU, sys consumption, because it's easy. Like if you think it's sys consumption and user consumption, right? And then the regular workload. If you split the sys consumption and it's low enough, and you know for sure your worst hook isn't bad because you can literally measure there is like BPF top, like those things that can give you, which are not like super accurate, but give you a good idea. And then if you go from there to checking the sys time of all the system during the run and the user land and memory of your own agent, then like I think you're covered, and then it's just about running functional tests and making sure that it doesn't deviate.
So would you like, you mentioned BPF top, would you compare some other tool when it comes to monitoring eBPF applications, or is just custom solutions that you could think of?
Not really. I've been using like my interest is how much overhead I'm adding to frequent calls. So my calculus is this, okay? So like for performance is like I do a benchmark, like a IO benchmark or an iPerf benchmark. And then I do again with my hooks installed and my logic working. And I see deviations in throughput. If there are none usually. And then I check BPF top. Okay, like despite the deviation in throughput, how much am I delaying the execution? X% of, and then, yeah. Because like it's like if 10, like, let's put this way, worst case scenario, 10 BPF map queries, like, and then a loop of up to 100 elements. This is nothing. Like, if you think of the socket buffer being unwinded into the protocols, like, of course, and I'm talking about XDP because XDP is fast forwarding, but like, if you think of all the complex logic the kernel does, then like, it's nothing, like what I'm doing.
Okay. Yeah. Last question before we go on to the demo. How many events per second can Gibril process? Is there a upper
Well,
limit?
that's the good thing. It doesn't handle events per second.
So that's the trick.
Yeah. There is
Okay.
no events per second.
Because you do the querying. Okay. Okay.
I can
understand.
parallelize, and then I can give you every cadence, I can give you processing of everything that has happened, and I can parallelize that. So I can give you in one CPU, and then the cadence will be delayed, but it's okay. Or I can give you like in 5 CPUs, like any other project, so it's,
Okay.
you have the control.
Yeah, that's good. Okay, let's go to the demo.
All right, let's see if I can share here. So as I was saying, the cadences idea is here. Like, what happens is I have different methods for detecting things, right? One of the methods is file access. The other is like through which domain or which IP I have talked with, and then environment variables or network flows. So, and here you can think of other detection mechanisms here, like for example, syscall, hijacks, and many others. And then in here is what I was saying about cache, if you open here, cache configuration, you can see like for what cache you should use for small devices or heavy IO, etc.
Cache is basically when you're retrieving the data from the kernel by a query, how long do you actually cache it in the user space, or how long the actual data is cached in the kernel?
Yeah, it's like for example, in here, it's 32,000 recent tasks, 64,000 tasks being kept, 32K comments, 32K arguments, and so on.
So basically in the kernel, let's say in a eBPF map, how long the tasks are retrained, how long can they still be queried from the user space, correct?
Yeah, but I don't need it to be as big as they are here. What will define that is your workload. And what will define this is also the cadence that you chose. I have 3 seconds just to show you how fast things can be, but I could put like 60 seconds. And then what you asked, like how many events can you do per second? If I run once every minute, then I would do everything that has happened in that run, probably in 3 seconds.
Yeah, I see.
And
Okay.
then, and then I run it, okay? And then here I have, like, as an example, some recipes here that are network related, phishing domains here, and then one execute example, and then another file example, just to show you how things work. And then I can do like touch. So like when it detects, in this case, it was a file detection. So when you have like a file detection, what happens is the format of the event will give you the file, which is the object that triggered that detection, right? And it gives like the file and all metadata around that file. So you can have like a post-porting analysis, which was like when was the last access or modification, who won it, if it's a regular file, etc.
So this is basically the remove operation of the file, right? Unlink.
Yeah, it's the removal. Let's touch it to see.
Yeah.
So now you can see open and close because it's a different operation.
Cool.
And then, apart from the file, what you have also like the ancient history of like all the processes that led with environment variables. So you have the ancestry here, like I'm running in cursor, blah, 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 and the parent is systemd, right? And then you have all the files that was ever touched by the binary up to the triggering moment. So I have all the libraries that were memory mapped, and then I have the mode for the libraries and who owns it, and then all the metadata and their sizes. And then I have the metadata for the event. And now if I do, like, for example, a curl to this, which it already detected. So this is like a phishing domain, right? So I have like
Yeah.
2 million bad reputation domains being monitored while it's running. And then it got like the phase, it got that there was like packets coming and going from both direction. It ended by remote, and probably because it failed to connect because there wasn't anything. But it's because it resolved the domain, I know it was like something I should have triggered, and then you can see that it was an attempt to connect to 4043. And then it does all the, if you had CNAMEs here, it shows you all the CNAME path resolution of the DNS up to the IP. And then you have the same thing as I said, but then you can see lots of files and flows, right? So since we had a flow, now you can see all the network flows from the proxies that triggered the event. I could have more if the proxies had more here. If you run a nmap, you're going to see lots of flows here. And then I have the libraries. And the libraries and each action taken to each of the libraries,
Nice. So you said there are 2 million phishing domains. Is this database of phishing domains something that you maintain, or is it public? How's with that?
It's a mix of things. Kind of 20% we do maintain.
Mm-hmm.
And then the other we pick from intelligent sources from elsewhere.
Okay, cool. And also, when it comes to network flows, do you have L7 network policies, or is it still like layer 4?
Yeah, so I do have the code, and it's ready for like very soon. It's like if you see, I'm doing literally like the entire DNS protocol inside eBPF already. And then the layer 7, the HTTP is okay, super easy. The SSL part, there are some gotchas in the library uprobe hooking, dynamic uprobe hooking, which is okay. I mean, so the code is already there, but I have to decide what to do with the detections, because the detections right now can be programmed, So I have to think of like how I would like to pass the HTTP payload, because like I don't want to enter that era where people confuses that we're trying to become another Cilium. Right now, I would adapt and connect with Cilium. That's my point, So to give an example, like on the reactions here, if I go to block a domain, for example, in here, okay? So whenever you spoke to www.example.com, it calls your YAML files JavaScript, and you can script this. And then in here, I'm literally calling netblock domain. So that means this domain from this recipe will be blocked. And then you can choose if you're going to block forever, for 1 minute, for however. The other reaction here is like a block using Cilium, for example. And then instead of Gbril enforcing the blocking on every host, I block when the threat happens, and I block cluster-wise. Then I can enforce using a Cilium policy, for example. I don't want to compete with them.
But are you actually performing like in-kernel policy enforcements when it's come to L7, or are you sending the traffic to user space and having a proxy?
No, I'm enforcing. So the net policy feature literally is like it can bypass. So it has some modes. So you can put the CDR mode here, you can put into bypass or enforce or just alert, right? And then you create your policies here. you can use CDR or even a domain. And let's assume that you want to forbid all.com, for example.
Yeah.
You can just put a policy here, and then whenever you try to access it, as soon as the DNS resolution happens, Gbril blocks the IP using BPF. So it's like in kernel. And then if you want to block the resolution itself, what I do is during the resolution phase, if you query that domain or anything like it, the resolution packets are going to be blocked already. You
Yeah,
can
but
choose.
we are talking here about egress, of course. What about ingress? Are you performing any blocks on ingress? Or what's the idea there?
Yeah, I'm not blocking per reverse, but the CID here are blocking. So the difference concept in between the reactions I told you and this is that this is action.
Hmm?
This happens like a firewall, and the other happens as a reaction to something that has happened. So
Okay.
if you put, this is a policy, right? So if you write a policy to block everything and only allow your internal domains and IPs, it will work like that.
Okay. Understood. Okay. So cool. I guess we came to the end of the demo. So thanks for joining me today. Thanks for taking the time. I think it was super technical, but I feel like a lot of people will also appreciate that kind of content. So thank you again.
Thank you for the opportunity.